Today we're going to spend a little bit more time talking about confidence intervals as they are one of the big components of inference and statistics, which allow us to make predictions about what is happening with the population. So as we talked about yesterday, we start with a distribution, and we unfortunately are not going to be able to get into a ton of detail, but of course in a normal distribution the mean is in the center. However, if we're trying to predict that mean, the best that we can use is X bar. So what we use in a confidence interval is we take that X bar and we subtract and we add on something that is called a margin of error in order to develop that confidence interval. So what we do for our confidence interval, as we did yesterday with the form, as we are only looking at a one sample confidence interval for a mean when we know the standard deviation. We start with X bar, which is our sample mean. Then we add and subtract our margin of error. This is our wiggle room or our margin of error. And what that is that's made up of Z star. We get that within the norm based on our level of confidence. Then we use the sigma or standard deviation for the population that is given to us in the problem, and n is our sample size. If we think about a few things here, if n gets large, then this fraction gets smaller, meaning the whole entire margin of error gets smaller, which makes your confidence interval smaller. In addition, if you have a higher level of confidence, let's say I go from a 95% level of confidence to, I know this is getting cluttered, to a 99% level of confidence, that is now taking up more area. 95% confidence would take up about this much of your curve. 99% confidence would take up that much. Therefore, your confidence interval gets wider as you become more confident. And the reason that is your Z-score also becomes larger. If you in the norm, your 0.025 or your 0.005 for each of those levels of confidence of 95 and 99%, you see that the Z gets larger. And I know that that is a lot of information, but basically based off of your level of confidence, the more confident you are, the wider your interval is going to have to be. The bigger your sample size, the better. And all of these things impact your confidence interval. If you're going to find your confidence interval, I would recommend using the Google form we did yesterday, opening that back up as a guide of how to plug this stuff into your calculator. So that's a really good way to kind of walk through it. So the form, you start with your sample mean, you add and subtract, you have to find your Z-score based on your level of confidence, and you have your standard deviation over root n. The thing that is beautiful is in our calculator, though, we can do it so quickly. So if you want to explore this, this will take you a very, very brief moment to walk through, and it'll calculate your confidence interval for your, like basically in a blink of an eye. So remember stat, and then we go to edit. So if you're going to enter data, as you're going to see in your Math Excel, you can go to stat edit and then enter your data into your L1. And of course, with the way Math Excel is, all of our data is going to be different, but that's where you're going to put your raw numbers. Then we go to stat and we go to edit. So go to stat, or I lied, not edit, you're going to go to test. And here is where you get all of your inference procedures. We are doing a Z interval. So Z for normal and interval for confidence interval. When you select that, you have the option of either doing data or stats. If you already know X bar and sigma, you can click on stats. If you don't, then you can go to data, which is what we did in this first part where we entered our raw data. You have to use sigma as given to you in Math Excel, the population standard deviation. Your list needs to be L1. Your frequency, don't worry about it. You're putting in your raw data. Then you put your confidence level, 95, 99, but it has to be 0.95 or 0.99 or 0.90, whatever your level of confidence is. And then you calculate it and it will give you your confidence interval. So remember that interval is taking your estimated X bar, not the real mean, and it's coming up with an interval in order to estimate that true average. As with great white sharks in the ocean, you don't know how much they weigh. I'm not going to be able to call them all in and weigh them one by one. We have to take a sample in order to make a good estimate. So use your calculator, use technology to help you. Let me know, of course, if you have any questions. And then we're going to move into just talking about other general statistics for the rest of the year.